So again, welcome to the webinar today for creating and working with virtual spectra data in FCS Express. My name is Sean Burke from De Novo Software, and I'm really happy to be here kind of guiding you through this kind of more practical webinar of turning some of that kind of standard cytometry data that you have into a sort of spectral, virtual spectral data set. So on the agenda today is what is virtual spectra. So we're going to spend just a moment or two kind of discussing that. Today's webinar is meant to be more of a kind of practical of how to actually use some data you already have to create virtual spectra. So we're going to be following on and looking at the workflows for creating virtual spectra from any of your kind of overdetermined instruments and data sets and how we do that. And essentially in FCS Express, it's a pretty straightforward process. We create a kind of spectral component or keyword for the data files that you want to use. We make sure all the data files in your data set have access to working with that keyword, so it can tell FCS Express that this is intended to be used as kind of virtual spectral data. And then, of course, we come in and we do unmixing with the virtual spectral data files. We're going to follow on to that. We'll show you, one or two data examples and applications of, using this kind of technology and this kind of workflow. And we're also going to discuss very shortly, just in about 4 or 5 minutes toward the end, the Starbright dyes from Biorad that were used in today's examples. I'll come back and talk about that as well. So to get started, kind of what is a virtual spectra? Essentially, it's using an overdetermined system where you have more detectors than parameters or dyes measured to arrive at some sort of spectral signature for controls and samples. And with this sort of data, you can use FCS Express to unmix those spectral data sets once you've created them and you have everything ready to go. And essentially what we have up here is an example image of what this kind of looks like, right? This is actually a single SANE control on a overdetermined system. We're using a Biorad ZE5 with 27 detectors turned on for use in a 10-color panel. I'm going to come in and talk a little bit more about that in a minute. But essentially what we're able to do is take this kind of standard cytometer, utilize the full range of the detector sets available on there. You can kind of see on the x-axis here, this first one I know might be hard, you might be squinting your eyes, but it says FL3A 525 35 488. The next one says FL4 593 52 488. So we're using, again, all of the detectors in the system to generate some sort of spectral signature that we can then use single SANE controls to do unmixing, apply that to our samples of interest, and kind of work with this spectral file. Now, in FCS Express, what's the workflow? How do we actually set this up, right? What we've done in the latest release of FCS Express 7 is make this very easy to do, and that's kind of what we're going to go over today. So one of the first considerations is setting preferences for parameter matching. I'm going to come in, I'm going to show you where to do that, how to do that, and why. We're going to create that spectral component to the data file, essentially using the new pipelines tools in FCS Express 7 to create a virtual spectra, to apply that to data files, and also to save that virtual spectra, the file that kind of tells FCS Express how to treat and work with this data in a spectral format, so that can be easily applied to every other data file in your data set. So you're not having to click around and do this, that, and the other thing all the time. When you load that into FCS Express, it will just be spectral, essentially, at that point. And we're going to quickly go through how to use those data files to perform unmixing, how to save that unmixing and apply it to samples and analyze, right? So again, keep in mind that it's kind of more of a high-level overview today of how these tools work, and we're excited to jump in with this. So let's talk about today's data sets. So today's data sets were acquired on the Biorad ZE5 with 27 detectors to arrive at our spectral plots and spectral signatures. It's an overdetermined system for the 10-color panel that we're going to be trying to analyze today. The panel is kind of outlined on the table on the bottom right, kind of standard immunophenotyping panel. But the kind of non-standard thing about this is that we've actually acquired some combinations for dye sets that you couldn't be performing classical compensation with really in any sort of software, but they could be unmixed via a virtual spectrum, right? So in the case today, in the data sets, we have CD3 and CD19 on BV421 and SBV440. And you can kind of see here in purple what those emission spectrum look like, right? So again, if we were coming in and looking at this and we were going to say, hey, can we do compensation on this? We'd probably look at it and say, no way we can use these together, right? We then also threw in BB700 and SBB700, including the Starbright dye data sets from Bio-Rad. And again, if we look at those emission spectrum, of course, we wouldn't be able to do classical compensation on this. But what we're going to do is we're going to use the 27 detectors in the ZE5 instrument to create this virtual spectra. We're going to perform unmixing, and then we're going to show you what that data looks like downstream. And it's actually very cool, the way that this all came together. Ahead of this, I want to say first a special thanks to Sharon Sanderson and Michael Blundell and all the folks at Bio-Rad for providing some of today's data sets, or actually providing all of today's data sets, their time and knowledge and effort that went in to kind of collect this data and using, again, a lot of these Starbright Starbright dyes, which are very useful, that we're going to come back with. We'll give you a kind of 4 or 5 minute overview about how those Starbright dyes are being used. So let's skip to the main event today. Let's learn how to perform virtual spectral cytometry in FCS Express. So with that, let me kind of close out a PowerPoint here. I'm going to move this out of the way, and we're going to open up a new layout in FCS Express. So let me go find that layout here on my other screen. I apologize, I got a lot of windows open on the other side here. But let's see if I can't get a layout opened up. Okay, so here we go. Here's a layout in FCS Express, right? This is the kind of workspace for performing your analysis. Now, what we want to do today is I have data for this 10 color panel, right? And again, what we've done, or what was done with this data set, it's data from the Bio-Rad ZE5, 27 detectors are all turned on. We're collecting information across all of those. We have single stain controls for everything that's in here, and we have this file labeled E6, which is our sample control that we want to perform analysis on. So if we want to create a virtual spectral data set from all of these, the first place to start is to get some data into FCS Express. So I'm going to take our sample data file and I'm going to drag it into FCS Express. I'm going to choose to insert a density plot for that data file. It's going to pop up. I'm going to change my parameters here to side scatter versus forward scatter, so we have something kind of nice to look at for this. And the first thing that you're going to notice about this data set, and let me kind of make this a little bit bigger and zoom in so we can see it, is that we have all of the detectors turned on, right? And we have area, height, and width for everything, but we don't have any sort of labels about, FL28 is CD4 FTSE or something like that, because this is intended to be used for virtual spectral unmixing. Now, importantly, we want to load this data in FCS Express so we can view all the kind of meta information for the name and stain of these parameters. Like this one says FL4-A 593 52 488, right? This is going to help us when we work with our spectral plots later to be able to come in and see which detectors are actually being used. Now, by default in FCS Express, we may just load up the name, we may just load up the stain, you may have your preferences set one way or another based on whatever it is that you may be working on. But you can always come into the File tab and Options, and in our Data Loading FCS File Options, there's options here to indicate what you want to load as the parameters in your plots and for compensation and for unmixing. So with these data sets, we found that loading name and stain was the most useful. So down the line, we can look at the spectral plots and we kind of know exactly which detectors we're looking at. So I would recommend, choosing name and stain for this. This is the Bio-Rad ZE5 instrument. If you're working with any other instrument, we can load that data. We can treat it like virtual spectral data. Just either find your instrument, find, if you're using a default FCS 3.0 file, 2.0 file, set that preferences. And of course, if you're working with spectral instruments already, you don't have to do this, right? They work really great right off the bat, and they're already unmixed, and the data looks awesome. So we're not trying to have to do these workarounds here. Okay, so I've got my preferences set correctly. And now how do we convert this to a spectral cytometry data file, right? So we're going to come up into the Tools tab in FCS Express and open up our transformations. And we're going to pull down the pipeline transformation. Now, what pipelines allow us to do in FCS Express is essentially string together whatever type of steps or data transformations that we want to perform on a data set. And what we call the root step in a pipeline essentially allows us to say we have a template file that has essentially all of these different parameters associated with it. And then when we perform other steps downstream in this pipeline, we can utilize all of these parameters. So very simply, if you have a data file inserted, you choose a new pipeline, everything's going to be automatically selected. So you're ready to kind of move to the next step, which is in our miscellaneous section here for merge to spectra. Now, what merge to spectra is going to do is it's going to assign the different parameters in your data set as being part of the spectral component for your virtual spectral data files. Now, again, you can see there's a ton of parameters here, and I probably don't want to use area, height, and width for everything. I just want to use the area detectors. I don't want to use side scatter and forward scatter. So we can make use of this little filter, and we can say -A, right? And that's going to pretty much show us all of our area detectors for this. So I can simply right click, select everything, deselect the 3 scatter parameters I don't need, and these are all the detectors that are going to be used in our virtual spectral data set. Now, the other thing I'm going to do here is give our new spectral parameter a name. I'm going to just call this my spectrum, right? We could label this really whatever we want. It's just a label. And that's going to allow us to name this when we access and work with the spectral plots. Now, what I want to show you here is that if I were to right now come in and try and insert a spectrum plot for this particular data set, FCS Express is going to say there's no parameter compatible, right? It just means that we haven't defined a kind of virtual spectrum for this yet, or we don't have spectral data. But what we do is we take this pipeline, we apply it to the plot by dragging and dropping. Now, all of a sudden, this data file has become spectrum, right? Or it's become spectral. And how do we know that? We can insert a spectral plot now, right? And you can see that we're now showing a spectral signature, a spectral profile for this particular data file that was not accessible before until we put in this data transformation. So let me close the pipeline. We don't really need that just yet. And I just want to give you one or two little notes about these spectral plots, right? When you're working with these, you might want to right click and format. There's a lot of kind of options that you can do, but we found that when you're working with these spectral plots, it's really nice to change the label orientation to 90 degrees, right? And what you're going to see is then we're able to visualize, what all of these detectors are across everything in this data set, okay? Now, the problem that we have here is, all right, well, we created a spectral component for this one data file, and we have a layout set up with a pipeline, and we applied it to this, right? We don't want to do this over and over and over again for all of the data files that we have that we want to analyze, right? In this case, we have single stain controls in one sample. Imagine we collected a whole bunch of samples as well. So what we do is in that transformations dialog with the pipeline, we can say, save this spectral component as an extra keywords file, okay? Now, the way that this works is we're going to choose to save it, and I'm going to come over here, and I'm going to call it my spectrum is the name of the file that I'm going to create. And over in this folder here, you can now see a keywords file for my spectrum was created. And if I open this up, all it really is FCS Express storing some data with the name that you called it, with all of the detectors that you're using in the system and what you're choosing to label them. And as long as you have this data file in this folder with all of these data, then these are essentially going to be somewhat converted to the spectral data file, right? Or it's not that they're going to be converted. FCS Express is going to recognize that you want to treat them as spectral data files if you insert a spectral plot. Now, at this point, right, we did two things. We created a pipeline, merged the spectra, we chose the detectors that we wanted, and we saved that file. At this point, we don't even need this layout anymore, right? It's very simple to kind of set this up. Let me open up a new layout. So I have a blank one open here. And what I'm going to do is close out this one. We could save it. We could use it again if we wanted to. Honestly, it's so quick and easy to set up the pipeline steps there that I don't have to do a save. But let's take a look at the other data files now, right? Previously, these didn't have any sort of spectral component to it. But if I take that DAPI data file and I insert a density plot for it, and I change to, again, side scatter versus forward scatter, so we have something to look at, I can come in and I can insert a spectrum plot for this data. The spectral plot will appear. Again, you might want to format your axes for these. I really like, again, using this 90-degree tilt here for the labels so we can kind of visualize what we're looking at there. And then again, we have that spectral component. And if we come into our data list, remember, we have 12 data files in that folder. And if I start clicking through these to my individual single SANE controls, you can see that we're building up the spectral profiles for these, right? We might want to do some formatting to these plots to smooth them or show lines and things like that. But the long and short is we have all of the spectral components that we need for that. It also means that, all of the kind of functionality that we have for setting a gate and applying that to a spectral plot, as you kind of move between data files, we get that live updating gating, and we can use that information. Okay. So again, at this point, we've created the virtual spectra for all of our single SANE controls or samples. Anything that we put into this folder is now considered this virtual spectral data file if we want to use it as such. But now what do we do with this, right? We need to perform unmixing, right? And how do we do that? So let me do a new layout again, and we'll kind of walk you through a little bit of how to unmix these data sets. Again, not going through in so much detail today. We have some great webinars about how to do unmixing in FCS Express and some of the quality control steps and things like that. But essentially, unmixing in FCS Express works just like compensation. If you've ever done compensation in FCS Express, what we do is come into the tools, but instead of choosing compensation, we would choose unmixing. Okay, and you get prompted to choose single SANE controls, and there's a few other steps that are going to be included here. So what we do is we go in and let me go find my spectral data sets here. And let's see where I've got these on my other screen. Give me one moment here so I can grab these and pull these over. All right. So these are our single SANE controls. What we'll do is we'll select them, click Open File, and everything is going to be loaded into the wizard here. Okay. Now, what we have to do is we have to label these, right? I can call this, unstained. We call these DAPI, right? I'm just going to go through and do the naming here. And again, this is pretty quick. I know it's another kind of extra step that you have to do, but it is something that's required. We have to come in and label all these, what we want to call them when we do the unmixing. So bear with me a moment as we just come in and quickly label these, and we'll show you how the control setup works for this, right? And you can see that all of these are currently set to use as self-negative, right? Now, if we had an unstained control and we wanted to use that for everything, well, we could set it as a negative control, right? And then every other data file here would use that file as a negative control. And if we wanted to, we could come in and say, all right, well, for DAPI, maybe we'll just use a self-negative, right? So you can come in and pick and choose how you want to utilize these different controls. For this data set, I do know that every single SANE control has a self-negative in there, so we don't have to use a universal negative. The other thing is, if you wanted to do autofluorescence extraction, right, you could set, whatever you wanted as autofluorescence, right? There's no negative control, and now we have an autofluorescence component, okay? The next step here is we'd set our gates, our parameters for working with our gates, just like we do in compensation. We're going to come in here and select the spectral parameter. Now keep an eye on the bottom of the page. As soon as I select our spectral parameter, FCS Express is starting the mixing process, right? So right now it's building up all the pages that we need for our spectral unmixing, right? And if I kind of move this out of the way, we'll close that down, right? You can see it's created a page for scatter plots, individual pages for all the different controls. And really what we want to do at this point is just like any other unmixing in FCS Express or compensation, we set the gate, we go through every particular single sane control, we set where it is that we want to set the positive and negatives, right? And we kind of go through and review all of that. So reviewing where to set, all the positive and negative controls in this data set is a bit boring for all of us to watch. So I'm going to kind of pull out a Martha Stewart moment here where I'll take something out of the oven that we've already prepared. And you can see that with the same data set, we've gone through, we've defined where the gates are, we've defined where our positive and negative controls are. If we wanted to review the spectral plots, right, we have those there and available to us. I know that there's one question that came through, and it mentioned that the spectral plots, didn't look so great when I first showed that, right? You can format these plots any way that you want, and I'll just give you a quick, highlight here with this particular spectral plot on the fly here. If we wanted to change the, the color levels, hiding outliers to smooth it out, if you wanted to use the standard level, if you wanted to come in here and, say interpolate the values to smooth it, if you wanted to come in and, say just show the line, right? We can do all of that, right? So you can kind of make these look however it is that's, appealing to yourself or easy to interpret by eye. Now, the other component here I wanted to mention is that, once we have all of this set up, right at the very end here, FCS Express will also automatically generate a visualized matrix, right? And again, what this is going to show you is for all the different unmixed parameters that we're looking at here, we're going to show you the contributions, and it's also going to come in and create a spillover spreading matrix. It's going to create a cross-staining index matrix, right? So you have all of that kind of information available to you and on the fly. Now, when I say on the fly, the other kind of really nice thing about this is that if I come in here and I decided, for CD4, I want to see kind of how my spreading matrix updates as I choose more positive or more negative events, you can see that we get live updating feedback in the spillover spreading, compensation matrix, or charts, right? Even as I move this smoothly on the fly, that scatter gate, all of those results are updating in real time. Right, so hopefully this is going to be a really powerful tool for you to help kind of set these gates and set these populations. Now, importantly, with our spillover spreading matrix, you may notice this really high number here with CD3 and DAPI. That's because there's a lot of spillover spreading from DAPI to CD3, or CD3 to DAPI. But the important point here is that DAPI is a live dead exclusion die, right? So we are only going to be using the negative stuff from DAPI staining. So this doesn't really apply. We do want to keep an eye on CD8 and CD4 when we look at this, and some of these other things that look a little bit higher, and we'll kind of point that out when we actually look at and analyze the data. But how do we do that? How do we make that jump from taking our unmixing that we've defined in FCS Express and applying that to our data files? Because we probably wouldn't want to use a 16-page unmixing analysis template or a mixing layout or a build-up template for doing an actual analysis. So what we do is we select the unmixing that we've determined and we click Save, right? And then we come over and we save it into the folder with our data, right? Call this My Unmixing. And what will happen, when I come back over and I look at that data, the My Unmixing is there. And essentially we can use that in any new layout to load up data, use that unmixing, and apply it to everything that we're doing. So let's actually take a look at that in a little bit of practice. Okay, so what I'm going to do is do, again, another new layout here. And we'll open this up and we'll bring in sample E6 again. All right, we'll take a look at what this looks like when it's actually unmixed for us here. And again, we're going to start with, say, side scatter versus forward scatter here, so we have something to look at. And what we'll do is we'll come into compensation and unmixing. We will import a transformation or import an unmixing, and we're going to grab that unmixing that we just created. Okay. So that unmixing is now loaded. Again, this is everything that we did in that other layout. We have it available to us. And importantly, what we can do is just say apply it to every data file, right? We can click on this apply to all plots. And, if we were to drag and drop gates out, that would automatically be applied. But if we insert a new plot, you need to get that applied real quickly. We can do that. And all the same sort of things that we do with compensation in FCS Express, by being able to make this as a default and import it and export it and use it over and over again, all of those same concepts apply, right? So if you're used to doing compensation in FCS Express, you can just use everything that you already know to do this unmixing. Now that the data is unmixed, we can actually start looking at these unmixed parameters, right? So we can come in, and we do have all the regular detectors that are in there, but at the bottom, look at that. That's all of our unmixed parameters. So if we're going to start setting up an analysis, we do something like change to the DAPI parameter, right? This one, I hate to start on something that's kind of squished down, but DAPI is one of these outliers here. So I do want to kind of show you that if you need to change the kind of width basis, you can always right-click and format, and set some sort of fixed by exponential point to kind of move that data around. But the point of this is we want to gate all that stuff out. We want to gate out all of the DAPI positives because everything that falls in here is a live cell, right? And then we can take that gate, we can apply it over to our scatter plot, right? We can set up an additional gate here. We'll just do something for lymphs in this case. And now this is kind of the magic part with, again, you remember what we were looking at previously in the system is this BV421 and this SBV440, right? You couldn't do compensation on this, the BB700, SBB700. Again, that's our CD3, CD19 on the low end, and it's our CD4 and CD8 on the high end of that emission spectrum. So let's take a look at how that looks, and we'll go to CD3. We can just kind of jump there. And let me put CD19 on the Y here, and we'll do CD3 on the X, right? And that's those two combinations, BV421 and BV440, right? Create a gate on the T cells here. We'll drag and drop this out and take a look over here at CD4 versus CD8, right? And this is, again, what that CD4 versus CD8 looks like. Let me kind of flip these around here. And if you remember, and let me kind of go point back to this, because again, I think this is some pretty exciting stuff, is again, that's these two emission spectras being unmixed in this under overdetermined system, even though it's only a 27 detector system. So obviously there's quite a bit of spreading there. I think it's something we could probably handle with some controls, but for the most part, this data looks really, really great, and we're able to do something that we were not able to do with classical compensation. Now, how does all this come together, right? Let's take another kind of Martha Stewart moment, pull over a completed out-of-the-oven analysis for this 10-color panel, and you can see that here's our CD16 versus CD14. Again, the B cells, T cells, 4s, 8s, 57s versus 4s and 8s, finally getting down to our T-regs here with CD25. Now, what I can tell you is when we looked at this same panel, when we had a classical compensation set up for it, the results were strikingly similar, right? Our percentages, everything that we did with unmixing versus compensation are the same. Unfortunately, we can't just show you compensation and how that would look like for this data set, because you wouldn't be able to perform compensation, of course, on this unless you're using the virtually unmixed data files. So again, with these data sets, some of the things that have kind of made this possible is this kind of being able to get some data sets from the ZE5 instrument, which are really helpful, and also the inclusion of some of these Starbright dyes that they've recently come out with that are really ideally suited for doing some sort of spectral unmixing or spectral analysis, whether it be virtual or using the dedicated instruments that are really, really excellent at doing spectral unmixing. And we've been keeping an eye on some of the questions. We're going to come through and try and answer a few of these. I know my colleagues have been busy answering some of them. But what you can see today is that working and creating the virtual spectra in FCS Express is very straightforward, right? Being able to utilize the pipelines in FCS Express to create the merge the spectra, and then saving the extra keywords files so you can use that with all of your data from your data sets is very straightforward, right? It only took us about 5 minutes to put that together in the webinar. Once you have that, you can use all of the kind of familiar tools that we have in there for unmixing. Again, they work just like our compensation has done in FCS Express for many, many years. And again, what we've kind of found so far is that the ZE5 instrument from Bio-Rad is very well suited for these experiments, right? Obviously there's going to have to be probably some optimizations and things like that that need to be done. It's not a spectral instrument, right? It is a classical cytometer that we are, kind of using as a spectral instrument because of the software technology that we have. But importantly, the Starbright dyes used today, again, kind of helped enable some of the more quality results for these data sets, and we're indebted to Bio-Rad for that. So again, I wanted to say special thanks to Sharon and Mike at Bio-Rad for performing the experiments, for putting in the time and effort to kind of do some of this initial testing to see if we can work with these these data files as spectral data files. Recently at Denovo Software, we've been having a lot of requests for folks asking, how do we do this? How do we perform virtual spectral kind of conversion of data files? How do we do unmixing on that? And again, today is meant to serve as a little bit of a practical overview of how to accomplish that. And we hope you can take that information home. You can download a demo. You can work with the version of FCS Express that you currently have and get that off and running. So with that, I wanted to say thanks for attending. And again, we really appreciate everybody coming out, and we'll be taking a few questions in just a moment.